This is another lesson on calculus, courtesy of A STEM Tutoring. My name is Henry. I'll be your tutor today. So today we'll discuss finding a first derivative and an application of the first derivative. So, for example, let's say you have the function f of x equals 3x squared. The first derivative, f prime of x, to find this, you take the exponent, bring it in as part of the coefficient. 3 times 2 equals 6. Then you subtract 1 from the current exponent. 2 minus 1 is 1. So this is x to the first power, which just equals 6x. The first derivative is, at any given point, the slope of a tangent line at that point on the curve. For example, if you have a simple curve here, we draw a tangent line at this point. So if we call this point x1, y1, then f prime of x1 is the slope of this line, that straight line. So let's consider an example from physics. Let me erase this first for a moment. Let's see if I can select more of this. Maybe not. Okay. I'll have to do this hard way and just erase. Here we go. Erase entire stroke. Much better. Okay. So keeping that in mind, we can apply this to a linear combination of x to certain exponents. For example, recall from basic physics the position x of t at any given time equals x naught, the initial position, plus v naught t, the initial velocity, times time, plus 1/2 a t squared, where a is a constant acceleration. So if we want to find the velocity at time t, that equals the derivative of the position x prime of t. So the derivative of a constant is 0, because if you had the function y equals a constant, it is a straight line that's completely flat, its slope is always 0. So this equals, t is our variable, so the exponent 1 out here comes here, 1 times v naught is still v naught, plus the 2 comes out here, times a half, they cancel out, and we have 2 minus 1 is 1, so we have a t to the first power, which is at. So the velocity at any given time is v naught plus at. So if we drew the slope of a line tangent to the position curve at any given point, it should equal the first derivative. So let's consider an example situation. Suppose x of t equals 7 plus 5t plus 1/2 negative 9.8 t squared. So we're assuming the initial height is 7 meters, the initial upward velocity is 5 meters per second, and the acceleration due to gravity is negative 9.8 meters per second squared. If we want the instantaneous velocity, x prime of t equals 5 minus 9.8 t. If we consider at the time 1 second, in this case x prime of 1 would equal 5 minus 9.8. Now let's look at a graph of this. So this red curve is the 7 plus 5x plus 1 half times negative 9.8 x squared. This presumes an initial height of 7 meters, an initial upward velocity of 5 meters per second, and the acceleration due to gravity of negative 9.8 meters per second squared. When x is 1, you can see the blue line that is tangent to the red curve at x equals 1. The slope of that blue line is 5 minus 9.8. That line is exactly tangent to the red curve at x equal to 1. So this has been a demonstration of how to find the first derivative and how to apply it to an actual problem in the sciences, in this case physics. Assuming you threw an object up at starting from a height of 7 meters with an initial velocity of 5 meters per second, and accepting the standard acceleration due to gravity of negative 9.8 meters per second squared. And that concludes today's lesson. Thank you for watching. If you'd like to learn more, you can come to me for some private tutoring. The first 1-hour lesson for new students is free. Try before you buy. You take no financial risk. The burden of proof is entirely on me to demonstrate outstanding service. Please check out my website, a-stem-tutoring.com, to learn more. When you're ready to schedule a lesson, please click the Schedule Lesson to schedule your first free lesson. As an added bonus for watching this video to the end today, when you contact me, mention the code free book. And if you do that, at our first tutoring session, I will give you a free copy of my book, Smart Suggestions for Student Success. I wrote that book with the intent of passing on as much advice and wisdom as possible to the younger generation, with the goal of helping high school and college students succeed in school, in work, and in life. Thanks for watching.